we will release QuTiP 4.7, and there a lot of work has already been completed for 4.7, and the things on this slide are by no means kind of all of them. If you go to the GitHub milestone for 4.7 on GitHub, you can see the complete list, but I sort of selected some highlights. So on the right, we have things that are kind of already merged into the QuTiP master branch. There's been a lot of test improvements, particularly moving some tests over to PyTest, and general cleanup in preparation, ready for the future of QuTiP and QuTiP 5. There's been a lot of work on the on kind of the build system, which was mostly thanks to Jake, and then on the sort of functionality side, there's now a steady state flow-k function, which can determine steady states for sort of Hamiltonians that are periodic in time. The state number enumerates and the kind of similar sort of state number listing functions are now about 30 times faster than they were in QuTiP 4.6. We have a more memory efficient MC solve, and we have the ability to put callable functions into EOPS for ME solve and SE solve. So before you could only put in kind of sort of measurement operators to extract information from the system, but now you can kind of put in sort of functions which are past the system state, and those can add numbers to your results that are returned by ME solve and SE solve. And as I mentioned, also just kind of many small changes that aren't listed here. The big things that are sort of still in progress, which we plan to get in for 4.7, are the importing of the Boffin hierarchical equations of motion solver, which Neil and I are working on together. That's looking quite good, and we're sort of in the sort of rounding it off and documenting and sort of adding test phase. I think the sort of highlights there are the new Hiom solver supports fermionic bars in addition to bosonic ones, and is a bit more flexible in how both bars are specified. And it also supports time-dependent Hamiltonians, where the old solver kind of mostly supported the Drude-Lorentz path and constant Hamiltonians. Whoops, there's a typo in the slide, but that should be the flow-k solver improvements, which is a pull requests contributed by Camille, and Camille and Eric are working on getting that in. And then very recently, there was a suggestion to add a QInstrument class by Chris Grange from Microsoft's kind of quantum computing team. And we're looking on that. I'm not quite sure whether that will go into 4.7 or 4. Or 5, but it's kind of looking like it might go in. So a QInstrument is just a very general kind of description of a measurement operation. So you can think of it as a list of possible measurement outcomes, and then the kind of operators on the system state that give the probabilities of those outcomes and the post-measurement state if that outcome is selected. And then QuTiP 5. A lot of things have already gone in. So you've heard a lot today about the data layer, and it seems to be working kind of really well. Behind the scenes, kind of time-dependent coefficients, the implementation is being unified into one class, and that's kind of now used sort of throughout kind of QuTiP, including in the new QObj Evo. So if you remember in QuTiP 4, there were different versions of QObj Evo. There was kind of a Python version and Cython version, and kind of those have all now been unified. And then above QObj, kind of alongside QObj Evo, there's now a new integrators layer. So the integrators are the low-level kind of integration functions used by the solver, and Eric's created a unified framework for those, and that's recently been merged in. And Yeah, and then kind of on the in progress side related to that, it's just the general reworking of the solvers, which is, I think, now kind of sort of nearing, well, at least we can sort of see the end of the road now, now that we have all of the kind of lower level things like the new data layer and the coefficients and QuTiP and the integrators all in place. And then, of course, we have QuTiP TensorFlow and QPy, which are, I guess, QuTiP family packages that implement new data layers. And good work has been done on those. QuTiP QIP has been split out. Apologies for the bad capitalization of QuTiP, but that was just the autocorrector not wanting to allow me to capitalize it the proper way. And Boxy has been continued to evolve kind of QuTiP QIP, and QuTiP QIP is acting as our sort of test case, really, of splitting out a very big, complicated piece of functionality from QuTiP into a separate package, but still making it kind of available by proxy inside QuTiP 5 to sort of ease migration if you have QuTiP QIP installed. Something that's Asir doesn't mention is that he's now also kind of interning at RIKEN as part of his MSc for a bit, and has started work on a QuTiP tensor network library. Hopefully that will probably that will be ready, or at least the initial version will be ready before QuTiP 5 is ready to go out the door. But as with the great thing about having these family packages is we're not actually dependent on any of these things being implemented kind of in order to release QuTiP 5. QuTiP Lattice has been split out. That isn't really under active development right now, but the person who wrote the original QuTiP.lattice did kind of reappear and start doing some bug fixing. So hopefully they will pick up the QuTiP Lattice package again. And then I think there's a whole bunch of sort of big things which are not related to features which we kind of need to do. So one is to actually just update at least a large fraction of our example notebooks to QuTiP 5. So that's there's examples of kind of how things work in QuTiP 5, and also there'll be a really good test of whether as a way to just sort of shake out any sort of bugs or missing features or things that used to work in QuTiP 4 and are now hard to do in QuTiP 5 and fix those. We need to do a general sort of guide and documentation update to make sure it kind of all matches the new QuTiP 5 functionality. There's a kind of a big merge of QuTiP master into dev.major that's needed. So that's kind of merging the QuTiP 4.7 changes into QuTiP 5. That's mostly to get kind of documentation and continuous integration infrastructure kind of merged into dev.major. And then we'll need to do an alpha release, and of course we need to write the QuTiP 5 paper. And then I have one question, which is not, well, we can discuss now if we need to, but otherwise we can always discuss it kind of later. But there's a question about whether we should make the dimensions of the kind of object being of the matrix, or the Hilbert space dimensions of the matrix being worked with available to the data layer somehow. And there are some good reasons for doing this, but there are also some really good reasons not to do this. And that's it.